I could tell you about Blackwell is this. This is a giant leap in AI, and it was designed for trillion parameter AI models. And this is, as you know, we're already at 2 trillion parameters. Model sizes are growing, about doubling every 6 months, and the amount of processing between the size of the model, the amount of data, is growing 4 times. And so the ability for these data centers to keep up with these large models really depends on the technology that we bring to them. And so Blackwell is designed also for incredibly fast inferencing. And inference used to be about recognition of things, but now inferencing, as you know, is about generation of information, generative AI. And so whenever you're talking to ChatGPT and it's generating information for you or drawing a picture for you or recognizing something and then drawing something for you, that generation is a brand new inferencing technology. Is really, really complicated and requires a lot of performance. And so Blackwell is designed for large models, for generative AI, and we designed it to fit into any data center. And so it's air-cooled, liquid-cooled, x86, or this new revolutionary processor we designed called Grace Blackwell Superchip. And then, supports InfiniBand data centers like we used to, but we also now support a brand new type of data center, Ethernet. We're going to bring AI to Ethernet data centers. Well, inferencing used to be easy. When people started talking about inference, generative AI didn't exist. And now generative AI is of course, is about prediction, but it's about prediction of the next token or prediction of the next pixel or prediction of the next frame. And all of that is complicated. And generative AI is also used for understanding in order to generate the content properly, you have to understand the context and what is called memory. And so now the memory size is incredibly large, and you have to have context memory. You have to be able to generate the next token really, really fast. It takes a whole lot of tokens to make an image. It takes a ton of tokens to make a video, and it takes a lot of tokens to be able to reason about a particular task so that it can make a plan. And so it really made inference a million times more complicated. And as you know, the number of chips that were intended for inference kind of fell by the wayside, and now people are talking about building new chips. The versatility of NVIDIA's architecture makes it possible for people to continue to innovate and create these amazing new AIs. And then now Blackwell's coming. And the software stack is complicated. The type of models that people use is complicated. There's so many different types. It's just going to be a giant market opportunity for us. The vast majority of the world's inferencing today, as people are experiencing in their data centers and on the web, vast majority of the inferencing today is done on NVIDIA. And so I expect that to continue. Copper demand grew throughout this quarter after we announced Blackwell. And so that kind of tells you how much demand there is out there. People want to deploy these data centers right now. They want to put our GPUs to work right now and start making money and start saving money. And so that demand is just so strong. It's really important to take a step back and realize that what we build is not a GPU chip. We call it Blackwell and we call it GPU, but we're really building AI factories. These AI factories have CPUs and GPUs and really complicated memory. The systems are really complicated. The amount of software that it takes to build all this and run all this is incredible. And so these AI factories are essentially what we build. We build it as a holistic unit, as a holistic architecture and platform, but then we disaggregate it so that our partners could take it and put it into data centers of any kind. And every single cloud has slightly different architectures and different stacks, and our stacks and our architecture can now deeply integrate into theirs, but everybody's a little different. So we build it as an AI factory. We then disaggregate it so that everybody can have AI factories. This is just an incredible thing, and we do this at very high volume. It's just very, very hard to do. And so every component, every part of our data center is the most complex computer the world's ever made, and so it's sensible that almost everything is constrained.